Hey, welcome to AP Chemistry with Mrs. Mays. Today we're going to look at hydrated compounds. We're going to learn how to name them and how to do some stoichiometry with them. So let's get started. First of all, a hydrate is any compound in which a specific number of water molecules are associated with each formula unit. An example is calcium ethanoate heptahydrate. Now back in the olden days they called this calcium acetate heptahydrate. But what does this mean? That means embedded in the crystal structure of calcium ethanoate, there are 7 water molecules. And they naturally occur as a part of the calcium acetate structure. So the only way to get rid of them is to heat up the hydrated substance and drive the water off. When we do that, we would get the anhydride form, which is the pure crystalline form of the compound without any water in the structure at all. So if you had just the calcium ethanoate, then we would call it anhydrous calcium ethanoate because these waters would no longer be attached. And the only way to do that really is to push the water away and then keep your substance in a desiccator so the water can't come back and attach to it. So to do hydration calculations, we would have to add the molar mass of the water molecules to the molar mass of the compound, because what you're weighing is both the compound and the water. So in sodium carbonate decahydrate, we would have 2 sodiums, then the carbonate, and then decahydrate, whoops, we use a dot. Decahydrate means 10 waters, right? So we have to add the mass of 10 waters to everything else. 2 sodiums, 2 times 23, plus 1 carbon, which is 12, and then 3 oxygens to make a carbonate. Oxygen is 16 grams per mole. So now I have my anhydride part, and then we can add the mass of 10 waters. So 10 times 18 gives us the mass of 10 waters. So get your calculator and add this up. In sodium carbonate decahydrate, oh, I didn't add up this mass. What was I thinking? Get your periodic table out and let's do it. So 2 times 23 so 10 waters so the molar mass is 286 grams per mole. So you can think of this dot that designates that it's a hydrated compound as an addition sign. Add up everything from the masses on the periodic table. No big deal. To calculate the percent of water in a hydrate, we would do like we normally do in a percent. You take the part that you're interested in, divided by the whole entire amount, and then turn that decimal into a percent. So let's work on the sodium carbonate decahydrate. The part of sodium carbonate that is water is 10 times 18 because there's 10 waters there. The whole entire everything was 286, right? Yep. 286 grams per mole. And then we'll turn that decimal into a percent. So I end up with 37% of this substance is water. So if I ask for the percent of water, then the water part goes on top. But if I ask for the percent of sodium, then we would just take the piece that is sodium, just like we do any percent composition. If you're working with a hydrate problem, you can always use the law of conservation of mass. So if I have 100 grams of a hydrate and 60 grams of it is water, then that means the other 40 grams must be the dry stuff, the anhydrous material, like everything else but water, right? So if you take the mass of water in a hydrate and divide it by the molar mass of water, you'll get the number of moles of water molecules. And once you get moles, you can go lots of different places, like molecules or whatever. Anhydrous cobalt-2 chloride has this characteristic blue color, while the hydrated cobalt 2 chloride hexahydrate is a pink color. This is a substance that's commonly used in baby diapers to be able to tell if the diaper is wet. If the kid has peed in the diaper, then the stuff gets wet and it goes from blue to pink. It's a signal to parents who aren't paying attention that, hey, the baby needs change. So we're going to find the molar mass for each substance, the anhydrous and the hydrate, and then we'll determine the percent of water that's bound up within the crystal structure of hydrated cobalt 2 chloride. So let's first find the molar mass. So cobalt 2 chloride is CoCl2. Let's add that up real quick. Cobalt weighs 58.93 grams. And chlorine is 35.5, but there's 2 of those. So this part is 129.83 grams per mole. Now that hydrate, it says hexahydrate, right? Let's check. Yep, hexahydrate. So that means 6 waters are attached to this in the hydrated form. So we have, for this molar mass, 129.83 plus the mass of 6 waters, where each water weighs 18 grams per mole. That comes from 1 oxygen and 2 hydrogens. So that is, let's see, 108 grams per mole for this piece, plus 129. The total is 237.83 grams per mole. So we just break it down and add up the masses of the dry stuff and then the mass of the hydrated stuff. And now we're going to do percent of water. So we take the part that is water divided by the whole entire everything. So water weighed 108 grams per mole, and the total amount of the hydrated compound was 237.83 grams. And then turn that decimal into a percent, and we get 45% of that substance is water. That's how we approach this type of problem. So if you can get from grams to moles and moles to grams, then solving problems with hydrates will be pretty straightforward. This problem is asking us to write a balanced equation, showing the hydrates being heated to form their respective anhydrous salts and water vapors. For this type of problem, you just need to know your prefixes. If we have magnesium sulfate heptahydrate, that means our magnesium sulfate with 7 waters. And if we were to heat this up, remember over the arrow, we would draw a little triangle thingy. Oh, that's not the arrow. There it is. Triangle over the arrow. And that means we've heated it, right? So we're going to break it apart into magnesium sulfate, and how many waters come out of this? All of them, right? So 7 waters are being released. That's it. That's the balanced equation. Boy, that's really sloppy. Okay, so now you try. Look up the prefix for tetra if you haven't memorized it yet, and look up penta and write an equation just like this one. Give it a try. Let's look at another example. Boy, this one looks hard because now we have way more numbers. Let's take our time and work it through. A 344 gram sample of hydrated calcium sulfate is heated to evaporate the water. The dry sample of calcium sulfate has a mass of 272 grams. What is the mole ratio between calcium sulfate, CaSO4, and water, H2O? So we need to find the mole ratio, and then we'll be able to tell the formula of the hydrate. All right, well, let's see. We have calcium sulfate with some unknown number of waters is heated up, and I get my dry calcium sulfate plus my unknown waters set free. What I know is that this piece weighed 344 grams, and the law of conservation of mass says that I still have to have a sum of 344 grams in the end. But 272 grams came from the calcium sulfate. So let's use subtraction to figure out what the water weighed. So we have 344 total, minus 272 in the anhydrous, and that leaves us with how much? 72 grams of just the water. Oh, that didn't work out. 72 grams of water. So now let's do moles. You guys are good at turning grams to moles. Let's do it. Calcium sulfate weighs how much? 1 calcium, 1 sulfur, and 4 oxygens weighs. So the calcium sulfate part, anhydrous, weighs 136 grams per mole. And then our water, how many moles is that? 272 grams. And we have 136 grams per mole. That's the anhydrous form. And I totally did not need a calculator for that. I was being lazy. So that's 2 moles of calcium sulfate in this experiment. Now let's look at the waters. We had 72 grams of water set free. And we know water weighs 18 grams per mole. So how many moles is that? 18 goes into 72 4 times. So if I write this formula, I would get 2 calcium sulfates for every 4 waters. Let's reduce that. They're both divisible by 2. So calcium sulfate dihydrate is the correct formula for the hydrated form of calcium sulfate. And our mole ratio, we better answer that question, was a 1 to 2 mole ratio. So this is kind of like what we are doing in our lab. We're going to work with grams and turn grams to moles so we can get simplest whole number mole ratios. Sometimes we start with a percent composition. In this case, we're going to do like an empirical formula. So we're going to change percent to mass, making the assumption that we have 100 grams to start with, and then we'll turn mass to moles. Once that's done, we're going to divide by the smallest. And if we have to, if we get decimal values, we'll times till we get a whole number. So that's our 4 main steps for an empirical formula. So the formula for a hydrate, that is 90.7 grams strontium oxalate. First we'll start with 90.7% and turn that percent to mass, just by writing a G there instead of a percent. Now let's do the molar mass of strontium oxalate. 1 mole of SrC2O4 is how many grams? Let's see, 1 strontium, 2 carbons, 4 oxygens, 175.6 grams. And that's going to give us, let's see, 0.5165 moles of strontium oxalate. Now let's work out the water part. We have 9.30% water. That means we have 9.30 grams of water. And for every mole of water, that's going to weigh 18.02 grams. That gives us 0.51667 moles. And I can do this one in my head already. Look, I have 0.516 or so divided by 0.516 or so. And that means I've got a 1-to-1 mole ratio, don't I? So this hydrate is easy. SrC2O4 dot H2O. Done. Okay, last problem. What is the formula for a hydrate that has 433.5 grams of molybdenum sulfide, that's a mouthful, and 66.5 grams of water? So we're going to do the same process, only since we don't have percents to start off with, we're already at step 2. We have grams, so change mass to moles and divide by the small and use a multiplier if we have to. So if I have 433.5 grams of molybdenum sulfide, then 1 mole weighs how many grams? Let's see, add them up. Molybdenum weighs, how much is molybdenum? Phew, that's a big one, 95.9. and then sulfur is 32. So that mass is 351.8 grams, and that means we have 1.04 moles of the molybdenum sulfide. Now let's look at water. 66.5 grams of water is how many moles? Each mole weighs 18 grams. So 66.5 divided by 18 is 3.69 moles of water. Okay, so let's change to the simplest mole ratio. We have to divide by the smallest, which is 1.04. And that gives me one of the molybdenum sulfides and 3.5 waters. All right, we're going to have to multiply because we can't keep the 1/2 around. We can't have a 0.5. If you get 0.5, then we're going to multiply both things by 2 to get rid of the half. So it's 2 MO2 S5s for every 7 waters. That's our simplest whole number ratio. And that's how we work with hydrates. Since the mass of water is pretty easy to work out, these problems shouldn't take you any time at all. We'll see you in class.